Exclusive or logical operator. Let us try to understand what is an exclusive or logical operator with the help of few examples. Example 1. Experience in Java or Python is necessary to attend the interview. Let's try to understand this statement. If you have experience in Java, you can attend the interview. If you have experience in Python, then also you can attend the interview. If you have experience in both Java and Python, then also you can attend the interview. That's why the or that is mentioned in this statement is called as an inclusive or, because taking one option will not exclude the other option. Both the options can be included. That's why the or in this statement is called as an inclusive or. Let's take one more example. If you buy a house, you will get 30,000 rupees cash back or accessories worth 30,000 rupees. Let us try to understand this statement. If you buy a house, you will get 30,000 rupees cash back or you will get accessories worth 30,000 rupees. But you will not get both 30,000 rupees cash back and accessories worth 30,000 rupees. That's why the or mentioned in this statement is called as an exclusive or, because choosing one option excludes the other options. But in the case of inclusive or, choosing one option will not exclude the other options. That's why the or that is mentioned in example 2 is an exclusive or. It excludes the other options when you choose one option. Now, let's take a look at the definition of exclusive or. The exclusive or logical operator is represented with a symbol which looks like a circle with a plus inside of it. Now let's look at its definition. Let P, Q be two propositions. The proposition P exclusive or Q is true if and only if P and Q are not the same. Let's look at the truth table. P, Q, P exclusive or Q. If P is true, Q is true, then P exclusive or Q will be false. If P is true, Q is false, then P exclusive or Q will be true. If P is false, Q is true, then P exclusive or Q will be true. If P is false, Q is false, then P exclusive or Q will be false. Let us observe these values. We can understand that P exclusive or Q is true only when P and Q are not the same. The same table can be generated with zeros and ones. P, Q, P exclusive or Q. If P is 1, Q is 1, then P exclusive or Q will be 0. If P is 1, Q is 0, then P exclusive or Q will be 1. If P is 0, Q is 1, then P exclusive or Q will be 1. If P is 0, Q is 0, then P exclusive or Q will be 0. From the above table, P exclusive or Q can be mathematically defined as P exclusive or Q is equal to 1 if P is not equal to Q. This formula can be verified for the values given in the table. 1 exclusive or 1 is equal to 0 because 1 is equal to 1. 1 exclusive or 0 is equal to 1 because 1 is not equal to 0. 0 exclusive or 1 is equal to 1 because 0 is not equal to 1. 0 exclusive or 0 is equal to 0 because 0 is equal to 0. That's why we say P exclusive or Q is equal to 1 if P is not equal to Q.